According to the National Center for Education Statistics, America's youth rank 19th among advanced nations of the world in science literacy, 24th in math. Their performance in the STEM subjects, science, technology, engineering, and math, is so poor, most are ill-prepared to take on technology-related jobs, nor do they seek them out.
8 o'clock, students should be on their way to their first period classes.
We want to see our young people prepared to go into the fields that really are going to pay a lot, but also make a big difference in the future of our country and the world.
I need everybody's focus up here for a second.
The irony is, most young people love the products of technology, like clothes and music devices, and the ability to communicate with friends. But it's as if they don't realize how these things actually came to be.
I think most kids really don't know what an engineer is. Even the word science or the word engineering can be very daunting for kids. How about thinking about a car or cosmetics? All of that is science and engineering in operation.
Alpha, beta, gamma, what are they?
But many students find STEM subjects difficult or boring. They don't connect math or science in the classroom with real experiences. So they turn off and away from opportunities in the vast technological world they live in. But does it have to be this way?
Go!
We need someone that's going to make the blades and propeller.
These high schoolers are doing a unique design challenge called Eureka Fest.
The air's coming from this way, we would be deflecting it down so we'd have it at this angle.
Sponsored by the Lemelson MIT program,
How big do you guys want to make the turbine?
teams of young people are racing against the clock to create a wind turbine capable of raising a trash can to the ceiling of Boston's Museum of Science.
The wheel to go and it'll make it spin the way we want.
Although this is an engineering challenge, like all real engineering, it embodies key principles in science and math that can enhance what kids learn in books and classrooms.
So if you added a little bit of curvature instead of making it straight down, would that do something?
It's gonna work great.
2, 1, fans on.
The students here come from a variety of social and educational backgrounds, but they have one thing in common.
Never would have thought it possible.
They are totally engaged in this activity, jazzed to the max on hands-on, minds-on learning.
So why are hands-on projects so important? We learn best when we get to apply the knowledge that we've acquired.
And introducing activities like these into the classroom is what many educators believe can turn STEM education around.
You want to move as many objects as you can in a 30-second period into the box.
With a grant from the National Science Foundation, Northeastern University, the Museum of Science, and Boston Public Schools recently created a professional development experience called Capsule to help Boston area math, science, and engineering teachers bring hands-on engineering challenges into the classroom.
Many teachers have never had the opportunity to do an engineering design project of their own as a learner. The work that I do really is focusing on the teachers as learners, and it's really focusing on how to help those teachers find or re-find the joy within their learning. If they're having fun and are excited about learning new things, I really think that that's part of what it's going to take to help the kids be excited.
If we can pick up duct tape, we can pick up the world.
On 3, 1, 2, 3, go.
Designing these picker-uppers demonstrates that engineering challenges can transform math and science concepts into fun learning experiences.
Kids need to be critical thinkers, problem solvers. And what gets at that is the engineering. How do we take math and science and connect it to something real? So if kids are not experiencing engineering in schools, then how are they going to be able to be those problem solvers?
First question is, how many people in this room have ever engaged as a college student in a capstone experience?
Capstone projects can be very enriching because students can take an entire semester to research, design, and build an original concept or invention. But most instructors here teach required courses
Well, we're a bunch of geometry teachers, and
with jam-packed curricula that make time-intensive capstone projects almost
come up
impossible.
with some short projects to introduce kids to capstones, going to match to the geometry standards.
So several are proposing shorter design challenges they believe will still enhance learning.
4, 5.
And they're ready to give them a try.
Oh, 2 at once.
This is the Boston Arts Academy, a public high school nationally recognized for its excellent arts curriculum. So one might expect that these young men and women will pursue a post-high school career in the arts. But a quarter of BA graduates go into science and engineering. One of the reasons is what headmaster Linda Nathan calls a natural affinity between the arts and sciences.
The arts is about mucking around. The arts is about playing, taking risks. That's what science is. That's what good science is.
And the time is now 8 o'clock. Students should
Finding new ways to attract arts-minded students to the sciences is one reason Ramiro Gonzalez, or Gonzo to his students, took the capsule training course.
All right, guys, I need everybody's focus up here for a second. I realized that the students were interested in the art form, but not necessarily interested in the way I was delivering science. And so I quickly realized that I needed to change my methodologies.
He is now introducing mini capstone projects into his chemistry curriculum.
What we're basically doing is building a filter. We thought of developing countries and how they have river water and it's not really safe to drink.
And the filter will be in here, and it's going to filter all the dirt.
I decided to go with one of Gonzo's ideas and create a game based around chemistry.
I have a good game program for you. It's fairly easy.
But there are serious challenges ahead. Ramiro's classroom is small and under-equipped, and initially he had no materials for kids to build anything.
I spend most of my weekends trying to find equipment, pieces of leather, pieces of fabric, things like light fixtures so that they can fit into their prototypes. It gets to be really, and then Home Depot and I have become really good friends. All right, so I'm going to let you have 3 more minutes to finish up.
Ramiro's biggest challenge, however, is time. His first priority is preparing students for the statewide chemistry exam.
We've become a state now that has decided we're teaching so that our kids can pass these tests. And I would really want to ensure that kids also do experiments, do portfolio work.
So with state tests, holiday performances, and course finals to prepare for, the chemistry kids face an uphill battle to finish their projects on time.
Because in order to push the water out, what has to happen to the boiler?
It has to contract.
It has to contract. What causes it to contract?
Anthony Iarapino teaches engineering at Lowell High School.
Gentlemen, our country's security depends on your Navy.
Unlike many of his math and science colleagues, he has the freedom to design his classes around creative, hands-on engineering challenges.
Yeah, nice.
When I visit schools and I see what I call organized chaos going on, where students are in huddles and working on something together, there is no teacher sitting behind a desk, and in some cases there are no desks in the way. I know that there's some rich engagement going on in that classroom.
Could be more than enough frequencies.
A former engineer, Anthony wants his students to make real-world connections with classroom learning. So he began looking for a curriculum that could help him do that.
Light her up and see if she'll run. School didn't have a formalized curriculum, so I began to put pieces together. But then I came across the Museum of Science course in Engineering the Future. And I thought, wow, that's something that would really be good for my background. So now we've applied a heat source, which is the energy. What is the heat doing to the boiler?
The ETF was designed to be a beginning awareness course of getting kids excited about engineering and the different possibilities around engineering.
When the boiler is contracting and expanding, that's the putt-putt you're hearing. Unless you get them excited, I don't think you have a high probability of getting them into the higher level of learning that you want them to get into. You also can't leave them just excited. You have to get them excited, and then you have to stretch them and pull them.
What is most encouraging about his classes is that STEM education is happening in a public high school, in a struggling factory town, and with a population of students so diverse, many are themselves first-generation immigrants.
So I came from Colombia 5 years ago. So guys, what was the time on it? It was really hard. The first day was horrible.
What's going on, man? You hit a bump.
I had no friends, and all the teachers spoke English. And
Making fun of me because I still
have no friends.
Give it a try. Let's see why you take time on it.
It was really hard because you can't communicate. You can't communicate to your teacher. You can't communicate to your classmates.
Alright, so let me get a seat.
I'm gonna go to college for 4 years and follow my dream, becoming an aerospace engineer, and like one day work for NASA or some cool company like that.
And Juan is not the only aspiring engineer.
After high school, I'm going to go into either marine engineering or marine transportation.
I'm actually going to the Navy to do engineering.
Yeah, I'm going to do it right.
Most importantly, these students have been given the skill set and the confidence to succeed in a technological world.
Nothing is impossible in life. That's what I think.
Also, you should all at this point be doing...
By most standards, Anthony's classes are well equipped.
10 robots, that's $10,000 right there. So I feel very fortunate to have all these toys.
But he is constantly seeking grants just to maintain what he has.
I'm lucky that we have a grant that funds most of the stuff that I do. If I lost the grant, the software that I use every year, $5,000 worth, may disappear. Over here, see how you...
And despite what he does have, he lacks the resources to do complex capstone engineering projects.
We just don't have the money to be able to invest as much as we could in all the equipment that would be necessary to make a capstone project really exciting.
But some high schools do have those resources. This is Blackstone Valley Vocational Technical High School. It offers all the courses one might expect in a Voc-Tech school, from auto shop to beauty shop. But this is far more than a place for young people just to learn a trade. It is a rigorous learning environment where students have to major in shop and pass standardized academic tests, like going to 2 schools at once.
We're going to use these to store our power.
Glenn Arnold teaches 4 engineering courses and coaches the football team. Blackstone is a Project Lead the Way school, meaning it has a comprehensive pre-engineering curriculum, including a capstone class for seniors to create an original design or invention. And here, students have well-equipped shops with skilled instructors to guide them.
I'm running at about 10 inches a minute when we're in there.
So seniors are free to design almost anything.
And my group's working on a keypad, but when you're using programs like iTunes, Microsoft Word, or Autodesk Inventor, there's a drop-down bar at the top of your menu.
So to simplify the process, we made a keypad that has the most common features of the program.
And so they can just use their fingers and pressing them instead of going up, clicking, finding everything.
This senior capstone class, Engineering Design and Development, essentially walks them through step by step the engineering design process. They are to start at brainstorming once they've determined a problem they're going to solve, and take that right on through to prototyping.
Seniors work in teams that combine their respective shop expertise with individual creativity and drive.
So we invented the smoke detecting hood vent, which causes when something starts burning, not steaming or anything else, but burning, physically burning, it will set off the alarm where it will alert the person that's burning, and it will turn on the fan to suck the air right out of your house so you don't have no problem with smoke in your house.
We found a photovoltaic cell smoke detector that instead of just, detecting certain amounts of heat or moisture, it detects burnt carbon in the air, and it would actually be able to, determine the difference.
The ideal for all engineering projects is to leave room for mistakes and lessons learned.
Well, about a month ago, when we were in a point of, problems.
We plugged it in, and it just popped, pretty much.
That's what happened.
We ended up sending twice the amount of power that was necessary for the smoke detector.
And it kind of exploded.
Yeah.
But we finally got to a point where we actually fixed it, and now it's fully operational.
It works.
The last thing I always tell them is the ultimate goal of the class isn't that your product is patented and sold the next day. It's that you've been through the entire design process and understand where you started, where you've gotten, and everything in between, and are able to report on it and potentially modify it to make it work down the road.
Many experts dismiss Voc-Tech engineering as just elevated trade education. But here, students are not only going to college, they are developing the skills to excel in careers or business, whatever they choose to do.
These are centers that are designed in a way to encourage problem-based learning and hands-on, minds-on learning.
And we'll take the crankshaft out.
It is a stellar environment. Most of the students are going on to college with a clear focus and a clear direction of what they wish to study.
I want to go to a 4-year college for hopefully mechanical engineering.
Computer engineering, biomedical engineering.
Probably aerospace engineering.
Most schools, however, do not have the equipment or expertise for this degree of project-based learning.
So you know what circumference means?
Kinda.
It's the distance around the circle.
But even schools with minimal resources and no engineering classes can reap the benefits of design challenges as learning opportunities.
I have scissors and I have cardboard.
You can actually do engineering design with cardboard and tape.
It's just like a triangle if you look at it.
So it's not a question of needing a sophisticated facility to do this hands-on project-based learning.
We need more cardboard, Mr. Linda.
Think about this. You're investing a very small amount of money, but the return for the learning that is going to happen for the students is immeasurable.
If we look at this, okay?
Brian Lenda teaches physical science at Southeast Alternative School in rural Massachusetts.
Right triangle right here. Right?
He believes hands-on challenges, like this mousetrap car, can have a big impact on his special needs students.
I made the shape of it with cardboard and made wheels with water bottle caps, and then connected a pencil to the mousetrap to connect to the string, and the snap of it made it move.
This is the big deal. Here we go, ladies and gentlemen. Go, go, go. All right.
The success of Angel's car has helped him on many levels.
About 37.
Angel, he had a low tolerance for frustration. He would refuse to finish projects because he was reluctant to revise anything. After working, through the engineering design process a number of times, he definitely has improved his ability to work through the entire process.
Regardless of the educational setting, persuading students to experiment, revise, and explore different variables
Slowly add small amounts of weight.
is the ultimate goal of problem-solving exercises.
Nice catch.
I have a separate circuit for...
And engineering teacher Chris Connors has made hands-on experimentation a central component of his courses at Pembroke High in suburban Massachusetts. An active participant in communities of gadgeteers and inventors, his approach to teaching is the polar opposite of the older lecture and learn paradigm.
Personally, I think the best way to learn something is to do it.
To support this learn-by-doing philosophy, Chris has students designing a variety of projects on computers and then feeding their designs to rapid prototyping machines like this MakerBot, a 3D printer that can melt, shape, or etch plastic, and this laser cutter that can cut cardboard, plastic, and wood. This equipment investment has helped students to design complex, capstone-like projects in a typical no-shops high school.
It's supposed to be like an underwater robot that's gonna go underwater and like be able to like pick things up, move around in a pool.
The students clearly enjoy working with the machines.
It's getting thrown into a whole new world. I had no idea something like this even existed until Mr. Connors had told me about it.
And they seem to be learning important math and science principles through the design process.
I learned a lot from all of this, just a lot of physics actually. Just the whole idea of everything that we do is science, like involves every subject. Just in designing these files on the computer, you have to use all these dimensions and make sure it will come out good in the end.
Maybe if we put that and just tied it down before we screw it down.
Exactly.
And then we can test it and see if it works.
For some students, solving problems and getting in the habit of solving problems really helps them to become better students, and I'm seeing a change in some of their personalities, that they're much more outgoing. Ready, set, go! All right. They're much more confident, and they're much more able to hold their own intellectually, which is great.
And they have the equipment, materials, and class time to finish what they started.
I could even change the way that the iPod would sit. It doesn't matter which way you put it in.
Resources not always available to others.
And so, before we get started, does everybody remember the engineering design process?
Last term, Ramiro Gonzalez's chemistry class projects fell victim to the end of semester crunch time, made worse by snow days. Many teams didn't even complete their projects.
Basically, we had to like make a lava lamp.
But this term, he's trying again.
We heated it up, put it in the lamp.
And his perseverance is paying off, with this class's lava lamp team the first to approach the finish line.
But what happened was the first time we added too much chloride, so the wax just stayed at the bottom and it wouldn't come back up.
So when you have a chance for your data analysis, for your expression...
Ramiro pushes his students to refine and improve what they've done because he knows that projects like these can help build something far more important than a lava lamp: self-confidence.
But I feel more confident that I can do chemistry because I didn't feel like I was good at chemistry. I was just like, kind of trying to ease on by. But now I feel like I can do something, so yeah.
Okay, thank you very much.
When I hear studies about, urban kids may not be as attracted to STEM subjects or go on to math and science at high enough levels.
We did a lot of research.
I wonder about the culture of the school, because it all starts with, is learning cool? So that's what Ramiro's playing with.
So for teachers, what kinds of things can they do to be creative and to create learning experiences for the students in those classrooms? From introducing CAD to Google Sketchpad to being able to build prototypes that they can physically hold in their hand. And I think that that's just inspiring for students. It is more challenging, but it's not impossible.
Helping our nation's youth connect with science, math, and engineering through hands-on, minds-on learning is what the capsule effort is all about. Bringing problem-based learning into STEM classrooms, offering new courses in engineering design, and working with teachers to engage students creatively.
That's how you do it.
The teacher has always been the difference maker.
There it is. The U.S. Navy is up and running. I often wonder to myself, why do you get up in the morning and why are you humming and why are you looking forward to coming to this classroom? And I think that when I look at a student, when I'm working with kids and I could see that their face lights up because they've learned something new, I think, no matter what they paid me or if they didn't even pay me, I think I'd still do this.
I've seen kids that are oftentimes disengaged in school, kids that I've seen basically people give up on.
We worked really hard on this.
If you believe in them and you have high expectations of them at all costs, they will rise to those expectations.
So you've got one with a positive side.
Our nation's youth should feel exhilarated by opportunities to shape the very world they live in, and to do so through technological careers that will define the 21st century.
Yes, you got to take those off.
So for the students and for the teachers who will guide them, it's up to all of us to encourage, prepare, and support their efforts.
We're looking to help teachers help children build their toolkit for the future. That toolkit includes some strong educational foundations, but also the skill set to embark on new challenges, to not be apprehensive, to work collaboratively, to solve those problems.
Go, 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 go.
That, in fact, is what we need for our country to succeed.